create code for lines and points. So at first, we'll create a point class. We will create the point class in this package. You see, every time we write a class, we need to specify what the package is. What is a package? We'll understand at a later point in time. But for now, just understand that we'll create the new class in this package. So we right click on it, we say new, and then you'll see it says Java class. So we create the Java class, we name it, and the name should be starting with a capital letter or an uppercase letter, right? So we say point, and a new class is created in this package. Great, so we have a new class. Again, what is public? We'll talk about that later. So what attributes did we talk about when we talked about points? It can have an X coordinate and it can have a Y coordinate. Now, these coordinates can be decimal numbers. They don't necessarily have to be integers, right? So we can have a double variable that is its X coordinate. Great. We can also have another double variable that will be its Y coordinate. And then we'll create the constructor. The constructor, again, don't worry about public. We'll talk about that later. The constructor would have the name, which is the same as that of the class. And we want to give the parameters to a point when we are constructing it. So the parameter at first would be an X coordinate, and the next parameter would be a Y coordinate. Now we can name them anything. We can name them input X, input Y, X, Y, it doesn't matter. Java would know that this is not the same as this. This is something that's coming from the outside of the class, right? Just like we discussed before. This is something that's coming from the outside of the class. It knows that. And so when we say this.x, it'll know that we're talking about this. But when we say x here, it'll know that it's coming from the outside of the class because it is a parameter of the point method. So we'll say this.x equals x and this.y equals y. What's happening here? This.x means this x, and this x here means this x. And this x is basically coming from the outside of the class when we're constructing it somewhere else, right? But inside the class, this x means this. So you see, even in IntelliJ, their colors are different because Java knows, or IntelliJ knows, that this x is referring to this x, and this x is referring to this x. Great. Now we have the constructor. Now we can have another method, which is getting the x coordinate. So we can have, let's say, get x coordinate. And we don't necessarily need to have any inputs here, right? We'll just call this method and the x coordinate will be returned. But what is going to be returned? A double is going to be returned, right? Because the x coordinate is a double. So we'll return a double. And then we'll just say return this.x, right? So it'll return this. We can also have another one which we can call get y coordinate. Again, we don't necessarily need to have any input parameter for this method. We'll just say return this.y. All right, so that takes care of our point class. Our point class is complete. What did we have in our point class? We'll have two different coordinates. We have a way to construct the point, and we have two different methods. One method gives us the x coordinate. If we have already created a point somewhere and we just want to know what the x coordinate of this point is, we'll get to use this method. And if we just want to know what its y coordinate is, we'll get to use this method. So our point class is complete. Next, let's create a line class. So we'll click on the package again and we'll say Java class and we'll just say line. So this new file is created here and we have the line class. In the line class, the first parameter would be its starting point, right? So starting point of the line would be the first attribute. And this would be what kind of an object? This would be a point object, right? So you see, when we say that we are creating a variable, the type can be a lot of different things. A type can be the primitive types. A type of that variable can be non-primitive types. And within non-primitive types, if you go back to that video, you'll see that class is also listed under non-primitive type. And point is a class, right? So we can say that a variable is of point type because point is a class that we created. Great. Now we can have another point, and that will be the ending point of the line, right? And so we have the starting point, we have the ending point, then we create the line constructor. Public is an access modifier. We'll talk about access modifiers later. Right now, we just create the constructor. And remember, a constructor does not have any return, so we do not have to specify a return type. So the constructor will have the same name as the class. We will construct a line using two parameters. The first parameter would be its starting point, right? And that starting point will be of point type. Second, we'll have its ending point. Let's say we just say e point, which is ending point, and that will also be a point type of parameter. Then we say this dot starting point equals s point, right? And we'll also say this dot ending point equals end point, all right? So now we've created the constructor for a line as well. Now we're going to define the methods for this class. The first method that we talked about is the gradient method, right? The method that'll give us the gradient of this line. So let's define the gradient method of the line. The return for this method would be a double because a gradient can come out as a decimal number. So double will be the return of this method. And so we'll say the name of the method, and then we'll define the specific task of calculating a gradient inside the gradient method. So we have the return type, we have the name of the method. We won't have any parameters here because we don't need the parameters, right? If we call this method for a certain line, it just gives us back the gradient because it already has the starting point and the end point, right? So, and the x coordinates and the y coordinates for that. So we don't need to give any inputs here. Great. Now, the only thing that's necessary for us is to define the specific task that this method would do. And the specific task is to get the gradient of the line. For getting the gradient of the line, there are two things we need to do. First, we need to find the difference of the y coordinates. Then we need to find the difference of the x coordinates. And then we need to divide the difference of the y coordinate by the difference of the x coordinate. Great. So let's do that. At first, let's define a variable named, let's say, y difference. And so at first, we need to get the y coordinate of the starting point, right? So how do we do that? We say this dot starting point, that's the starting point here. This dot starting point, dot, you see, it gives us the things that we can access. So we'll just access y right now and say the starting point's y minus this dot ending points y, right? So this gives us the difference of the y coordinates. Now we'll have another variable named x difference, and this will give us the difference of the x coordinates of the 2 points. So we'll say this dot starting points x minus this dot ending points x, right? So we now have the two differences, and now we can calculate the gradient very easily. Let's say we name it grad, or for gradient, and we'll just say y diff divided by x diff. And that is our gradient, and we'll just return this gradient after. And so our gradient method is complete. Next, let's define the length method for a line. So when we have a line, we want to know how long it is. So we'll have another double return because the length can be a decimal number. So we'll have a return type of double, and we'll say find length, right? And again, we don't necessarily need to have any parameters because we already have the line, we already have the starting point, the end point, and inside these points we already have the x coordinates and the y coordinates. So that's all we need. We don't necessarily need any input from the user or from the outside that we would require to find the length. And so let's try and write the specific task that would calculate the length of the line. Again, at first we need to find the difference of the y coordinates, which will be, again, let's say ydiff, and we'll just copy this. So we have the difference of the y coordinates and we have the difference of the x coordinates. Now we need to square those differences, right? And then add them together. But we need to square them first, right? So let's just square them right here. We'll say math.pow2. And we'll say the same thing here. And once we do that, we want to change the name, of course, because we have squared them now. And now we have the difference of the y coordinates squared and the difference of the x coordinates squared. Math.pow just allows you to do exponential calculations, right? So if you want to find, let's say, 4 cubed or 4 square, you would just say math.pow, and then you'll say what you want to square, and then you'll say 2, because then that'll give us 4 square. If you want to do 4 cubed, you do this. If you want to do 4 to the 5, you do this. So math.pow actually is something that's already built in Java. We looked at the math class, remember? And we found that math class has a pi variable already defined in it. In the same way, math class has a pow method already defined in it, and you can use that to calculate powers of numbers. So that's exactly what we used here, and we found the difference of the y coordinates and squared it. We found the difference of the x coordinates and squared it as well. And now we'll just again have to use another method from the math class, which would allow us to get the square root of these two things when we add them together. So let's find the length. The length would be of double type as well. And we'll use the method sqrt. So that means square root. And inside square root, we'll add the y difference and the x difference squared. So we'll say x diff squared plus y diff squared. And in the end, we'll just return length. That's our length method done as well. So now let's create a couple of points in the main method, because remember, whenever we want to execute anything, we want to execute it from the main method of the main class. So in the main class, let's create a couple of point objects, and then using those point objects, let's create a line object and see whether or not we can find the length of that line. So now we'll construct a point object using the constructor that we wrote here. So remember, the point objects constructor signature is this, right? So we'll say point, and then we'll give it a x variable, and we'll also give it a y variable, which will ultimately be its coordinates. So let's say we want to create our first point. We'll say point, let's say we want to name it our first point, and we'll have to say new, and then we'll have to write down the constructor, remember? So this is how we create a new object. So the first object that we're creating is a point object, and then identity, the name of that point object, is our first point. And so let's write the constructor. The constructor would first need an x coordinate. So let's just give it an integer x coordinate for now. Let's say it's 3.0, right? And let's say we want to give it a y coordinate of 4.0. So there you go. That is our first point. Now let's create our second point, which is another object, a completely different object, but it is a point type of object. So let's create our second point. Again, we write the new keyword, and then we write the constructor. And the constructor will have the x coordinate of our second point and the y coordinate of our second point. That's how we defined it in our class, right? We first input the x coordinate, and then we input the y coordinate for the constructor. That's exactly what we're doing here. So let's say the x coordinate is 7.0, and let's say the y coordinate is 10.0. So this is what it looks like, right? We have a point 3.4, that's our starting point, and we have a point 7.10, that is our ending point. Now let's create a line object from these 2 points. Let's look at how we need to construct a line. Let's look at the constructor. We defined it as line, and then we need to input 2 points, okay? So we already have the 2 points in our main class. We'll just use those 2 points to construct our line. So let's think of the name for our line. We can just say our line for simplicity. And what type of object is this going to be? What type of object is our line going to be? It's going to be a line type of object, right? And so we'll say this, and then we'll say new. New is that keyword that creates new objects. We then write down the constructor. Line is our constructor, and inside this line we need to provide two different points. The first would be our first point, and the second one would be our second point. All right, so now our line object is also created. Great. How does this actually look? This is what it would look like when we draw the line between the two, right? And the gradient for this line would be this minus this y and this minus this x. So it'll be 4 minus 10 divided by 3 minus 7, which is 6 by 4. The negatives cancel out, which gives us 1.5. So the gradient for this is 1.5. What's the length? The length would be the x difference squared, which is 4 squared, plus the y difference squared, which is 6 squared, root over, right? And that would be 16 plus 36 root over. And if you put this in a calculator, you'll find 7.2111. So these are our results, 1.5 and 7.2111. So let's see if our methods for the line actually work. So how do we access those methods? Those methods are for the line class, right? And remember that whenever we want to create an object, we can only create an object from a class. And that's what we did. We created the point object, our first point, from the point class. We created our second point from the point class. And these two are separate objects, completely different objects. But they are of the same type of object. Great. After that, we created a line object. This is our line object. And this object is of the type line. We created it using our class line, using our class's constructor, remember? So when you want to access the methods that are in these classes, the only way you can access those methods is through the object. Only the object can access these methods as they are defined here, all right? So you cannot just say the name of the class line.gradient. You cannot say that, because even though line has a method called gradient, you cannot say that because you cannot access this method without an object. But we can access this method using our object that you've already created. So the object that we've created is our line, right? And that is a line type of object. This line can have a gradient. So if we write our line, you see now this is all right. This is not giving us an error. So this actually gives us a gradient. So in order to test it out, we'll print it out, all right? But in order to understand what this is, let's also print something out for our own understanding when it actually is printed out in the output. So let's say we say gradient. Also, we want to find out whether or not our find length method works or not, right? So how can we access find length? We can only access find length through the object that we've created. The object that we've created is our line. So that's the only way we can access our find length method. So let's do that. Our line dot, you see the ones that you can access populate here. So we'll just say find length. And this does not give us an error. Great. What we want to do is print it out. So let's print it out. And again, for our own understanding, when it actually is printed out, we want to know what this is. So we'll just add something here saying length. Great. Now let's run this program and see whether or not it works. So you see, it actually gives us a gradient of 1.5. It gives us a length of 7.2. And this matches what we predicted. So you see, in this way, you can represent anything in this world. You can represent anything you want that you can see around you as objects using code. And you can create anything you want using that concept. So now we've created a point and a line. If we now want to create shapes, let's say we want to create a triangle and a rectangle, you can do that too. You just need to write more classes and more code. From those, if you want to create 3D objects, let's say cubes and spheres, you can do that as well. And from those, if you want to now create even bigger objects, like using a lot of different cubes. If you want to create a structure, you can do that as well, right? So there is no limit to what you can do using these concepts. Everything can be represented as objects, and everything can be thought of using these concepts. Remember one thing, every programmer who's built anything amazing started with similar concepts such as these, just basic concepts such as these. If you want to create, let's say, Instagram, if you want to create a software that is a game or a graphics design software, it doesn't matter what you want to create. You can create anything using coding. And this is just the beginning of your journey. And I'm really excited that you're learning all of this. I hope you're enjoying it as well. One last thing that I should tell you is that the access modifier for this should be protected, and the access modifier for this should be private. Again, why this is so, we'll talk about when we talk about a concept called encapsulation, and there we'll also cover what these access modifiers really are. In one of the next videos, we will simulate a game, and it will be a very simple game, and we'll be creating classes for players, and then we'll see which player won. And we'll be doing that using the same concepts of objects and classes. See you in the next video.